Welcome to a lesson with Dr. Powell. Let's investigate the derivative of cosecant inverse. We restrict cosecant just the same way as we restrict sine. From negative pi halves to pi halves, maybe taking out any kind of asymptote that might occur. So sine itself looks something like this on that interval. Cosecant looks something like this. Notice how cosecant is always decreasing. Its inverse will always be decreasing too. So you think if you have a decreasing function, you swap your x's and y's to reflect across this line right here, you end up still getting something decreasing. So we're going to expect the derivative of this always to be negative. Let's get started. So we have y is equal to cosecant inverse of x. Take the cosecant of everything. Take the derivative with respect to y. We get negative cosecant y cotangent y. And then we take a reciprocal. dy dx is equal to -1 over cosecant y cotangent y. Then we need to write everything in terms of x, cosecant of x. So it's the same kind of deal as we had before. And you'll notice, well, let's work through it. So we have cosine squared y plus sine squared y is equal to 1. You can divide everything so we have a relationship between cosecant and cotangent. So divide everything by sine squared. Doing so will give us cotangent squared y plus 1 is equal to, cosecant squared y. So solving for cotangent, we end up getting this -1. So this is x. So we end up getting this similar thing, x squared minus 1. But we want to ensure that this is always negative, so we tack on an opposite value there. And we have gotten it. That is the derivative right there, very similar. So I sped through a couple of the details right there, only because it's very similar to what we did for secant inverse. So this right here is the derivative of cosecant inverse. Thanks for watching.